Hello, folks. How's everybody? I hope you can hear me well. As you know, I'm on the road and I'm on vacation, so I took my computer with me. But my computer has low sound. I can't do much about it. I've got enhancements over there at my home, my usual home, and I don't have it here. So I hope you can hear me. So if you can't hear me, please let me know. But again, I can't do much about it. All I can do is ask you to turn your speakers on or whatever. Okay, so let me say the following. We had a discussion this week at the Rational Scientific Method group in which is on Facebook. So if you don't know about it, you may want to join and participate in such discussions with a few at least intelligent people. And we had a discussion about the word object. What is an object? What is a thing? Okay? And once again, let me see if I can ask someone if you can hear me well. I hope my sound is coming out okay. Anybody can answer, I really would appreciate it. Give you a minute to respond there. Can everybody hear me okay? No? Nobody can hear me? Okay. Echoing. I don't know what to do about it. It could be the room I'm in. It could be the room because it's a big room, but I don't know. Should I speak louder or should I speak? Okay. Thank you. I'll try to speak lower. Anyways, we had a discussion about the word object. Okay? And one of the issues that comes up is why do we need to talk about objects in physics? Is that a key word? Is that an important word? And all I can do is put up what I call the golden principle of physics. And that's how I'll start today. It goes something like this. Physics requires an object. You can't do physics without an object. Okay? So that's the starting point. And some people say, well, hold it. Aren't there concepts also in physics? Don't we use concepts? I mean, like distance or position. We use energy, at least some people do, mass, etc. Don't we use concepts as well? And the answer is that you need to know the context. You need to understand the context. Here's the context, okay? What do we mean when we say that physics requires an object? It means specifically this. It means that you cannot move a concept. You can only move an object, okay? That's the issue. The issue is that in physics, we cannot move concepts. We cannot say that we're going to move love or even location or any concept. You can't say you moved a field, that you transferred energy, that you moved a mass. That's the issue. The issue is you cannot move a concept, okay? You might say, well, everybody knows that, right? I mean, it's self-explanatory, or most people at least would think it's self-explanatory. And maybe not. I mean, I'll give you some examples here. Why it's not self-explanatory and why we've been doing exactly the opposite. We've been moving concepts, at least for the last 100 years. Here's one example, okay? And this is how they discovered the first black hole, Cygnus X1. Now, this is an illustration, okay? This is not the real thing. But what you see here is that you've got a star, which is the visible thing there that's twirling, that's orbiting, and it's orbiting around nothing, seemingly around nothing, okay? And so that's how they came up and they said, well, look, what's at the center of that orbit is a black hole. And what is a black hole? Well, a black hole is all mass and no volume. Well, that sounds pretty much like a concept to me. In fact, let me illustrate it my way. Here's my way, okay, of illustrating that, okay? We have mass, and we have something, in this case a turtle, going around mass. Okay, so what is mass? I mean, that's what a black hole is, all mass and no volume. This is a perfect illustration of that notion, of that theory. And the question is, by what mechanism does the mass attract or compel the turtle to go around? Here's a better illustration of that. That's what mass is. Mass is kilograms. That's all it is. That's how we measure mass. Mass is a mathematical concept. And for someone to say, look, we have mass, we have kilograms somewhere in a region of space, and this compels a star to move around the kilograms. Well, you have not explained the kilograms. You have not explained the mechanism. Okay, you have not explained, what is the mechanism? By what means does the kilograms, a mathematical concept, compel, a turtle to move around or a star? And here's another version of something similar to that, also related to gravity. This is a bird flying on Earth. Okay, we've seen this many times. We have this experience. What would this bird do on the moon? Well, it would fall flat on its face. That's what it would do. And you say, well, yeah, of course. And what's the reason for that? Well, you say, well, there's no air. But then you're missing the point. See, the point is the bird fell down, okay? Fell towards the center of the planet. Or in this case, the moon, right? The satellite. But the correct interpretation is that the air on Earth was holding it up against something that was already pulling it down. And so what you got to identify is that something. And the question is, you can't put a concept in there. Like I've been discussing the last couple weeks, a lot of the dissidents who object to general relativity, what they do is they say particles. But I'm not sure you can explain this with particles because, again, one of the problems you've got is this situation where you got particles coming from every part of the universe. Supposedly these are ether particles or whatever particles these theorists imagine. And the question is, why would the particles push down on a person here on Earth with a higher acceleration compared to an astronaut in this case, right, which is farther away from the Earth? In other words, that guy has no gravity pulling on it, or barely any gravity pulling on it from the Earth, whereas the person, that same astronaut on the surface of the Earth, would be pulled down at 9.8 meters per second squared. We know this. And so the question is, if you're going to explain this with particles pushing down on the astronaut, you're going to have a little bit of trouble explaining this difference. Okay? You're going to have to really go out of your way, aside from the fact that particles cannot explain other phenomena such as magnetism and light and the workings of the atom, as I discussed this in the past couple of weeks. But the question is, you can't put a concept in there. And if you don't put an object in there, you're essentially doing gravity with spirits. That's essentially what you're doing. If you don't put some kind of object, if you don't make the object visible, what you're really doing is putting spirits in there. I say concept spirits, and you say, well, what's a spirit? We've always talked about spirits in traditional religions. Well, here, let's define the word spirit. Spirit is a concept used as an object. That's what a spirit is. Okay? We have synonyms such as energy, soul, field, consciousness, wave. Any person using those words is introducing spirits. Okay? Introducing concepts as objects. This specific one is walking down the stairs, this concept. Okay? This is the problem. The problem is that you cannot continue doing gravity with concepts. You must put an object. Now, particles are object, real particles, right? But again, you have that problem where, how do you explain the difference between the acceleration of gravity here on the surface of the Earth and the acceleration out there in space, near the Earth? For example, the satellites that go around the Earth. Okay, so yeah, we need to define the word object because it's crucial to the discipline. And it starts out with the what I call the golden principle. You need to establish some kind of cornerstone. And that cornerstone is that you can't do physics without objects. You can't move concepts around. That's the point I'm trying to make. Okay. Now you may say, well, how difficult can it be to define the word object, thing, entity, medium, whatever you want to call it, substance? We should have done a great job after 10,000 years. We should have that definition down pat, it should be perfect. And it's quite the contrary. Here's the Wikipedia definition of the word object. Okay, here you'll see it. And you can see that they have several definitions, which, by the way, a lot of people use simultaneously or jump from one to the other without even knowing. Okay, so here you have it. Object in philosophy, a thing, being or concept. So according to philosophers, a thing is a concept. So they don't see any difference between a concept and a thing. And then they put a being, which is a live object. So they have all these different categories. They lump them all in one boat and they say, okay, I'll sell it as a package. Entity, something. Already we have a problem. We have the word something in there, which is the word we're trying to define. But it says something that is tangible and within the grasp of the senses. Well, what senses? I mean, what happens with an object that's on the other side of the universe, a star? It's not tangible. I can't see it. I can't smell it. Can't taste it. Can't hear it. Is there another sense? I mean, I don't know. You tell me. No, an object not necessarily, within the grasp of the senses. And if you do that, what you're doing is introducing a second object, you. So you need two objects to define the word object. You need an interface. You need touch. You need see. You need taste. You need smell. There's got to be, the moon is not an object until the asteroid hits it, which means you also have to run an experiment, a test. Object, abstract, an object which does not exist at any particular time or place. Okay, so they have objects and abstract objects, whatever that is, another category. So they have all these little categories, each one for a specific purpose. It sounds very ad hoc to me. And then you have a physical object. You have the abstract object and the physical object. Abstract and physical are opposite, are antonyms, right? So here you have a physical object. What is that? An identifiable collection of matter. Well, a collection of matter already is many objects. So they're saying a collection of many objects. That's what a physical object is. And so it's a circular definition because you haven't defined what an object is. You're just saying it's a bunch of objects. That's all they said there. What is matter is any substance. So matter is a substance, right? Okay. That has mass and takes up space by having volume. Okay. So we have all these circular definitions. They're all synonyms. They're using synonyms to define synonyms because they never defined the word. And the last one is the worst one of all, where people confuse the word object with the subject of a sentence, that which we can talk about. Okay? And so what happens, people say, well, I can talk about motion. I can talk about an orbit, the orbit of Jupiter. Does that make orbit a physical object? Just because it's a noun? Just because it's the subject of the sentence? So all these notions that these people have introduced over the years, specifically the philosophers, they go through all this analysis And at the end of it, they say, we don't really know what an object is. That's where we are today. And you say, well, Bill, you're trying to sell me a Whopper there. Well, no, I'm not. Look, here it goes. This is the Stanford Encyclopedia of Philosophy on the word object. You can look it up yourself. I'm just going to give you here the rundown. And that's what it looks like. Okay? This is what they have on their site. These are just the headings. Each one of these is analyzed separately, and if you read it, well, you got to go to a psychiatrist after that if you read all of that and understood it. Just look at some of the titles there, and you'll see what they've analyzed over the years. And the worst part is when you reach the end, you still don't know what an object is. And no one anywhere in philosophy on planet Earth knows what an object is. They keep debating this stuff over and over and going over the same issues over and over. Here, let me give you an example. I just pulled out of this a few lines for you to see where the philosophers stand on the word object. This is again from the Stanford Encyclopedia of Philosophy. Okay, this is what it looks like. Okay, and I'll just read a couple here that says. Here we have objects are in space and time. Properties are not. That's one of the statements that you'll see in there. Objects are sense perceptible. Again, they want to introduce senses, okay? And, for those of you who've heard of my proposal, my hypothesis, which is the single thread. Okay, here's the single thread. How do you get to it? How do you identify the single thread? Do you identify it with touch, smell, taste, hear, or see, or any of the senses? No, the only way you can approach it is through the mind. We know we cannot touch light. We know light. Not only you cannot touch it, but you cannot see it. You cannot see the mediator of light. Okay, and for sure nobody asks whether you can smell or taste it, but that's a valid question as well. I mean, can you hear light? Light itself, the mediator of light. And no, the issue is the only way to approach, invisible entities that Mother Nature uses is through your mind. You got to think about it. You got to imagine it. You got to visualize it. Okay. Here's a couple more from the Stanford Encyclopedia. It says, in ordinary language, we are inclined to call only material objects objects. And that's the only one they got right. People confuse the notions that we have of ordinary speech, of our ordinary world, and those are objects to us. The table's an object, the chair's an object, and we get so used to that when you try to define it very specifically for the purposes of physics, people immediately, jump up and say, no, that's not an object because of this, and that, and then go back to the ordinary speech notions, our ordinary everyday notions of what an object is. That's not what an object is for the purposes of science or physics, okay? In physics, you have to define it precisely because you're going to be giving a dissertation, you're going to tell someone your theory about whatever. You better know exactly what an object is. You can no longer bring the notion of ordinary speech, of our ordinary life, and say, well, you know what an object is. No, I don't. Please tell me, because no one has ever defined this word throughout history. If the word object is a cornerstone, even if it's necessary to do physics, it is surprising that no one in the last 10,000 years has written a book of physics, a textbook of physics, where they start out by saying, oh, this is what an object is. There's not a single textbook of physics, don't take my word for it, there's not a single textbook of physics that begins by telling you what an object is. And if you do need objects to do physics, well, it's a big omission, I would say. It's like you're missing the ABCs of that book, or whatever you wrote. One way to explain a thing is to mark out what it does. No. First, we don't explain a thing. We don't explain a table. We point to it. Say table. And someone knows what I'm referring to when I say table. And then, no, we don't define it by, first, we don't define objects. And second, we don't define them by their usage. We don't say a table is that where you put a plate on, or a chair is what you sit on. We don't define words. We have to point and name what we're referring to so that the ET, the extraterrestrial, knows our language, understands what we are referring to. Okay? Thing, essence, or nature could take a variety of forms. The real definition of X might be put. To be X is to be Y, or the real definition of a category F, to be F is to be G. What in the world does that have to do with the word object? They go through all this nonsense about identity, and A equals A, or A is equal to B. What is all this nonsense? What's that got to do with defining the word object? And this is what you'll find on their side. According to the bundle theory, objects are a bundle of properties. That's what an object is, a bundle of properties. What sense does that make? Can we use this in physics? Bare particularism maintains that objects have their properties as constituents. They are subjects of properties. Again, subject, instead of thinking of what you're going to talk about, right? Or the items to which the properties are attached by instantiation. They have all these notions that they developed. They overthought this thing, way overthunk it. And they come up with all these arguments and theories, and all I want is a definition. What is an object? Please. You don't take all this time to define the word object. I just need a definition. I need to know what an object is for the purpose of physics. And they go through all these theories of all these opinions of what an object is to this guy, to that guy. Who cares? I need an object. I need a definition I can use in physics. And you won't get it from the so-called physicists, really mathematical physicists. Why? Because they don't do qualitative stuff. They let the philosophers define the words for them. Okay? So if you want to know what an object is in mathematical physics, you don't go to the mathematical physics department. You go across campus to the philosophy department and let them define it for you and tell you what an object is. And this is the stuff you'll see. You see the problem? It's a little bit of a problem because you got one discipline that has nothing to do with physics defining the words for physics. And when you confront the mathematical physics, here you have a mathematical physicist who's got a PhD. He studied 10 years at the university. He's an expert, right? He knows about the moon, space-time, everything, right? And you ask him the question, what is an object? And he goes in there and he said, let me look it up. And he goes to the dictionary or the encyclopedia. Huh? What do you mean you got to look it up? What happened? You skipped kindergarten? I mean, this is stuff that you should have had, in your first class. What is an object? And the guy has to look it up. And what they do is they regurgitate. They just transcribe what they read. They say, oh, this is what the Wikipedia says, or this is what Stanford says. That's what they do. And you can see by the other definitions there that, they're all the same. It's all a lot of analysis. And you can look at the article for yourself, right? You just look up the word object for Stanford Encyclopedia, and you'll see where the philosophers are today. It's a good synthesis of what all the philosophers on Earth are thinking when they talk about the word object. And they're the ones who define it for physicists. And this is what you'll see. You'll see all this nonsense. At the end, you will not know what an object is, okay? So, yeah, we don't have a definition of the word object. And that's the first problem, because we absolutely need to define the word object for the purposes of physics, because we can't do physics without an object. Why? Because we can't move anything which is not an object. We can't move concepts around. We can't move spirits. Okay? And you might say, well, has someone in the history of humanity defined the word object, especially the way I do, or the way I'm going to define it? And here you have a rundown. This is just a synthesis of maybe among the most important philosophers and physicists, so-called physicists, who've tackled the issue throughout time, okay, in different eras, okay? Everyone from Confucius all the way to Simone de Beauvoir, okay? And None of these people ever hit it on the nose. None of them. I mean, you can look them up. You'll say, well, look, so and so. Aristotle mentioned something about form. Euclid mentioned something about form. They never, none of these people, none of them, ever came up with the golden principle. You need an object in physics to do physics. And even if they were not physicists, they should have zeroed in on that principle. You need to really think that you need an object to do physics. And if you need an object to do physics, you need to define it concisely and not with roundabout arguments saying, well, let me tell you this and let me tell you that, my opinion. And no, you got to just give me a definition. None of these people did that. Okay, none of them. So if one of these is your hero, well, I'm sorry to tell you, I'm going to trash him. So you'll hate me for it. And I'm one of the most hated guys, so don't worry about it. So just quick synthesis. Object is not equal to exist. Object is not that which is used for this or that. We don't define the word object by its usage. Okay? And an object is not a collection of, which is known as mereology. Okay? In other words, we don't look at what comprises an object, because if you look at what makes up an object, you're already invoking 2, 3, 4 millions of objects. So you haven't defined it. You can't say an object which is made out of objects. That's what you're saying essentially. So no, an object is not a collection of whatever. Okay. So what an object is not? Well, here we have it. Some of you have seen this in the past. This is what an object is not. It's not what we can see. It's not what we can touch. It's not that which has mass. It's not that which has volume. It's not that which moves or can move. It's not made of parts. Again, mereology. It's not something you visualize through time. It's known as temporal parts. A theory of object has come up sometime in the past where you don't see the table in one go. You know, when you enter the room, it's like you see it piece by piece in microseconds. So you see the front of the table first, and then as you go along, you see the rest of the table. Or if that's too small for you, you look at the room. You know, you don't see the whole room in one shot. You see it from one side of the room to the other. That's the notion they have. Okay? Temporal parts. It's not that which we can use in a sentence. It's not the subject of a sentence. Not in physics. You can't use the word orbit as a physical object. If people talk about the orbit of Mercury or whatever. You cannot use the word orbit as a physical object. So just because you use it as a noun, just because it's a noun in ordinary speech, just because it can be used as a subject of a sentence, it doesn't automatically translate into an object. It's not that which exists. Exist and object are two separate things, and I'm going to be covering that next time. Exist, that's another big monster. It's not that which is 3D. We have objects that are 2D, as I'm going to show you in a minute. And it has to be standalone. In other words, it can't be a dependent object. In other words, you've heard of a magnetic field. A lot of people think magnetic field is a physical object. And the main thing, the reason they think they treat it as an object or have in the back of their minds that it's an object is because it does things. It can, this so-called field, this spirit, right, attracts another magnet or attracts iron filings. So it has that influence, that physical influence, and people say, oh, it's something. And what is something? Well, something is an object. It's a thing. That's the logic. And the problem with the word field is that, it's not a standalone object. You can't have a field, a magnetic field, without the magnet. I can't bring a magnetic field and put it in the center of the conference room for you to see it from every side and say, oh, I see what a field is now. You can't do that with a field. It's like I always give the analogy with the angel's halo. Without the angel, the halo is just a ring or a plate, depending on which. if you want to talk about halo, you need the angel. The angel gives it that holiness. And the same thing with a magnetic field. The magnetic field is not a standalone object. It's a dependent object. A true object has to be standalone. Okay? If it's the only object in the universe, that's the only one God made and then he disappeared, right? It should stand alone. It should stand alone. It should be, and you have to conceive of it as made of a single piece. You can't say, oh, it's made out of all these little parts and atoms, and no. It's made of a single piece, because a table, when you point to it, you're not thinking of the millions or gazillions of atoms that comprise a table. That's not what a table is. A table is not 1 gazillion atoms. That's not what a table is. That's Mariology. All you said is it's made out of atoms, what it's made out of. No, when you point and say table, you're referring to the whole shebang as if it were made of a single piece. Okay? Okay. Let's move on here. I want to get to the real good stuff. Here's my definition. Very difficult one. An object is that which has shape. Okay? Why shape? Shape is the only universal property of all objects. All objects have shape. Some objects can be seen, some objects can be touched, some you can smell, not see. You've got gases that you can smell, but you cannot see. Phosphine you can't smell either. I can't think of one right now, but there are gases that you cannot see and you can smell, and let alone hear and other senses, right? But yeah, an object is that which has shape. Very simple. Now we're done. We don't have to think about all those different. Methane. Okay, thank you. The point is that you don't identify an object with your senses, because if you do, you're already introducing another object. You need to have an interface and you need to have a test. You're saying essentially, if I don't see it, it's not an object until I see it. So the table is not an object until I see it. And that creates a problem for the blind man, because he can't see the moon. And so the moon is not an object for him because he can't see anything. So we have a problem with that type of definition. Okay, so what's the problem? Well, some people always raise this issue and they say, okay, I got you, Bill. Okay, you destroyed all my proposals. You said it's not a volume, it's not mass, it's not see, touch. Okay, so tell me, what is shape? This is where they want to get you. Say, so what is shape? Why don't you define shape? Okay? And I've been at it for 20 years, believe me. So I've collected a few arguments. I'm just going to synthesize them for you today, okay? And then I'll turn on the questions. I'll go with the questions. But let me just give you a synthesis of the arguments, okay? Let me give you a synthesis of the arguments of why we don't define the word shape, okay? So let's pay attention here, so we don't repeat ourselves, right? It turns out we didn't require a precise definition of any of the other criteria. We didn't ask you, well, what did you mean by mass? What did you mean by volume? What did you mean by see? What did you mean by touch? What did you mean by motion? No, we don't. All we need to know is the difference in criteria. Are you going to use see, or are you going to use touch? Are you going to use volume? Are you going to use motion? That's what we need to understand. The ordinary meanings of those words suffice to compare them and find a criterion that we're going to use to define the word object for the purposes of physics. That's what we're trying to do here. Okay? We're trying to define the word object for the purposes of physics. We want to be able to use it consistently in a dissertation. And so if you're going to use see, touch, motion, etc., and you need another object, that's no good for physics because you're first requiring a second object and then you're putting a test. You're saying, I need to see it move. And if it doesn't move, it's not an object. And I need to see it. And if I can't see it, it's not an object. Now, if I can't taste it, it's not an object. If I can't hear it, it's not an object. So it becomes subjective. So no, you don't need to know what all these words mean precisely. All you need to know is which criterion you're going to use to define the word object. Okay, then the other one is the devil's advocate wishes to show that no word can be defined precisely, scientifically. You can't use it consistently. That's what they're saying. That's what the person is aiming at, like saying, well, you can't define any words. All you're doing is semantics. That's the goal, because he lost the battle. He said, well, it's not volume, it's not mass. I want to make sure that it's not shape either. And the way I'm going to get there is by saying that you can't define shape. And so the problem is that, the third one there, why didn't the devil's advocate ask you to define that, which, or has? Are these any easier? Can you define, can any of you define the word the, the article, any better than shape, or which, or has? In fact, has is a big problem also, because in ordinary speech we say, oh, I have. But see, you can have a headache and you can have 10 cents in your pocket. And to have one and to have the other don't have the same physical meaning. I have love. Is that the same thing as having, a pair of pants? And so you got to go through all this analysis to find out that the word have is going to be very tricky. Okay? You got to go through this whole process. Then by caving into the devil's advocate's demand, you just go in endless iteration. Okay? He's just going to keep asking you, well, define this, define A, define B, define Z. He wants you to define word after word after word. He's just going to keep you all busy all day. No, the buck stops here. The buck stops here. We define based on a criterion. We choose one of the criterions, we're done. We don't have to keep going and say, well, what do you mean by shape? And what do you mean by the word that you use to define shape, and so on down the line? No, the buck stops there. You got to stop at some point, because at that point it just becomes extreme devil's advocacy, and there's no real purpose to that endless iteration other than to show that, oh, you can't define any word scientifically. So we don't start. We don't do any physics because we can't define the word object. Is that what we're supposed to do? Okay, and then we do not need to define shape. We merely need to distinguish between criteria. Okay, that's the bottom line. And for those who still want to know what shape is, well, you can do it on your own. Okay, and here it is. Here's a test that you can run to prove shape to yourself, the definition of shape. You just go to a kindergarten, and show the toddlers a ball and a cube. Some kind of, take one of his cubes and take a ball, and hopefully they have the same color, the same material, the same everything. And just ask the little kid, what's the difference between these two objects? And he says, it's a shape. And so he'll teach you. If you miss kindergarten, he'll teach you what shape is. Okay? We don't need a super awesome or unimaginable definition of the word shape. We just need to know if shape is different than motion, if it's different than see, touch, volume, mass, subject. We just need to find if there's a difference, between these words. If you can tell the difference between shape and motion, you got it made. Okay, if you know the difference between those two words, you're okay. Okay, and so I'm just going to finish off by saying that these are the foundations of physics I'll be touching in the next presentation, maybe in the next couple lectures. I don't know if we'll get to all of them. And specifically, I want you to note that first one, something. Not, what is an object? Something. And that word right at the bottom, exist. Okay? Exist is the other important word of physics. Physics is the science of existence. Physics tries to understand and explain what exists. Okay? And yeah, that's the subject matter of physics. You need to know or try to understand, try to explain. When you give a dissertation, when you try to explain something to someone, you try to explain your theory, specifically a mechanism, right? You need an object. You absolutely need objects, and that's what exists objectively. And then, of course, you're only going to talk about things that exist. Physics does not deal with squares and ideal cubes, Superman, Snow White, all those things that the Greeks, used as the foundations for geometry. All those figures. Physics doesn't deal with that. Physics deals with real objects out there. And the only ones we have to figure out today are the invisible mediators. How does Mother Nature do her stuff? And she doesn't do it with concepts. She doesn't do it with spirits. She does it with objects that we can't see or touch or smell or taste or hear. So you won't be able to go to the lab and prove through an experiment what that object is. You're going to have to grab a beer, sit back, do some armchair physics, right? And think and try to visualize how she could be doing her little magic. Gravity, invisible magic, right? Gravity, magnetism, light, electricity, the workings of the atom. And out there in space, how does she do these things where a star goes seemingly around nothing? Dark matter, why a galaxy rotates and the stars on the outer edge not only travel faster than the ones on the inside, but don't fly away. All those invisible mechanisms is what we need to explain. And the only way we're going to explain them is by trying to visualize what physical object Mother Nature is using as mediators, what secret agents she uses. Okay, I'm going to turn on the questions. Let's see if I have any. Otherwise, I'll see you next week. Let's see, we got here. Physical outline. Okay, I got no questions. You got 2 seconds, and otherwise I'll see you probably next week. Remember, I'm on vacation, and when I get home, I'll return to my regular lectures. Okay, well, if you do have questions, please raise them at Patreon. You don't have to pay anything. You just have to sign up. Okay, so put them in the Patreon page, and if you do put them here, well, I won't answer them in YouTube. What I'll probably do is, if the question is good, I'll address it in the next lecture. We'll see you then. Bye bye.